So could it be possible to get a clear image of me reflected in this brushed metal finish of my kitchen balance? So let's pop it over here so we've got a chance to do that. And to try and produce the reflection, I've got an infrared camera and a visible light camera on this phone. So let's have a look. Well, in the visible light image, not much there, a bit of a bright patch from the window, but in the infrared, hopefully you can see a clear image of my face. Let's give it a little wave. So why is that we can see a clear image in the infrared, but we can see almost nothing of a clear image in the visible light? In the infrared, where we see a clear image, we are getting specular reflection, where the angle of incidence equals the angle of reflection from a smooth surface. But whereas in the visible light, we're getting diffuse reflection or scattering because we have a rough surface. But why is the surface smooth for infrared, but rough for visible light? Well, the reason for that is that the wavelength of the infrared is about 10 times longer. And for waves, if the wavelength is long compared to the size of the roughness or imperfections, then we get specular reflection. There is a nice analogy to understand what's going on. A large football, like the long wavelength infrared, bounces predictably from some gravel, whereas a small bouncy ball, like the short wavelength visible light, bounces much less predictably from the gravel. So now you know why a brushed metal surface will produce a clear infrared image, but will not produce a clear visible light image. Thanks to Klaus-Peter Mollmann and Michael Vollmer, from whose paper the idea for this video came.